Hello everyone. In today's world, we are facing a great challenge. A challenge I'm certain we will overcome, just like we overcame all the great challenges we faced in the past. May God keep us and our loved ones safe. Looking at the bright side, we are better equipped today than before. And one of the advantages we have had since the start of the corona pandemic is the hastens of digital transformation and how we are fighting this pandemic using emerging technologies. Welcome to Hope Hackathon's digital meetups from Thinktech, an initiative sponsored by the Ministry of Communications and Information Technology. Today, we have the session Gaming Development Platforms. Your moderator is Abdallah Konash. Welcome, Abdallah. Project Manager of Manga Productions. Abdallah works in the field of game design and development in Saudi Arabia. He has 10 years of experience in this area and aspires to lead the advancement of the game industry in Saudi Arabia. Abdallah, the floor is yours.
Thank you so much. Hi, everyone. Welcome to this session. I'd like to introduce our guests here. We have Mr. Jeff Peters, and Dan Millward, and John Cobbs. Mr. Jeff, if you mind introducing yourself?
My name is Jeff Peters. I have been in the video game industry making product for about 30 years now. And everything from arcade games to console to PC to mobile, including stints as an executive at Electronic Arts. Worked in Japan with SNK, and have worked on major franchises like Mortal Kombat and NBA Jam and Monopoly and Tetris, and it's been fun. Currently, I am COO and founder of Spark XR, working on leading edge VR technologies and experiences.
Cool, thank you so much. Next, Mr. Dan.
Hi, I'm Dan Millward, the CEO and founder of GameFruit. I come from a mobile games development background in New Zealand. We've developed a platform called GameFruit, which is an online platform for making and learning about game development. We've got over 500,000 users that are mostly students and their teachers. You could say that we're a game engine for kids.
Awesome. Thank you so much. Mr. John?
Hi, I'm John Combs. I'm currently the founder and design director for Utopos Games. I've been in the industry for almost 20 years. I've worked as a designer, engineer, producer, CTO, all kinds of stuff. I've worked on big franchises like Command & Conquer, some Lord of the Rings games, Supreme Commander. I've done a lot of strategy games. So yeah, I've worked at the likes of EA and Gas Powered Games, places like that.
Cool, thank you so much. So I'll be starting with you, Mr. John. So to kick off this session, let's first describe what a game engine is. Can you tell us that?
Sure. A game engine is, in my opinion, basically you take all the really hard parts of making a game work and giving it to everybody to use so that they can focus on building the content and how the gameplay works rather than how it renders, how it gets packaged up into a game, how it handles sound and all that stuff. And then giving anybody opportunities to use their engine through tutorials and distribution networks, platforms, that sort of thing.
Okay, cool. So there's definitely multiple usages of the game engine. So and the target audience of them also might be different. So for example, Dan, you're targeting kids more than professional companies. Can you tell us more about that?
Yeah, for us it was about it's about making a game engine that's suitable for a particular demographic. So and thinking about your audience. And our audience is very much teachers, students, and so we had to develop something that was easy enough and suitable for them to use, and that also meant creating resources and working with teachers and students. We launched GameFruit hoping that our customer would be other independent game developers like us. And then when we launched, there was like thousands of students, their teachers, using GameFruit. So we had to kind of pivot and reinvent ourselves and learn how to create a product for that audience. So what we've done is we've made an engine based around 2D game making, and we've made it easy for young people to develop and code games.
Okay, thank you. Now, currently the game engines, people say that it's becoming more easy to use. So, Jeff, can you tell us more about the history of the game engines in general, and how easy are they becoming right now?
So first, looking back in time, each game developer used to have to create their own environment in order to make a game. They had to develop their own renderer. They had to figure out what type of art formats to create to put in the game, what code to use, and how that all comes together. Very expensive, very time-consuming. Jumping forward to today, because the world had become so fragmented of everybody building their own engine, we now have companies that's all they do. They don't make games. They make the engine specifically that the rest of us can put code and art and sound into to make a game. From an indie point of view, there's actually a lot of great options where you don't have to build that environment yourself. You can essentially download it and start working with it. Unity is currently the biggest one in the world and probably the most common for indie developers. Unreal is one of the highest ends used for most of your high-end AAA PC and console titles. You also have smaller engines like GameMaker, which is mostly working with 2D images and sprites, or even Cocos 2D, that provide you other options and a lot more control of how to make a 2D game. There's a few others on the side, like Lumberyard from Amazon. There's the Cryengine. Each of these have different pluses and minuses and pros and cons, but the good news is if you want to go and make a game, you can start by downloading any one of these engines based on what type of game you want to build, and just start going. You're free to start, even borrowing code from other people or downloading assets. It's actually a great time to be a game maker compared to what it used to be.
Right. So continuing in this topic, when we talk about the current business models of the game engines, we noticed that lots of the game engines currently shifted to a free model. So why did that happen? And in terms of cost or licensing, is there any kind of constraint regarding those topics?
I can kick this one off. I think that the first answer to your question about free is, well, we like free stuff. And our world has evolved into free to play and free to try and free to use becoming the dominant business model. It used to be everything that we would pay before we got to try it. And now whether you're a PC gamer or a mobile gamer, okay, free to play is pretty much winning out. So on the tool side, which is what an engine is, okay, we like free there. So Unity, Unreal, and most of the other engine makers had to figure out, okay, what is a way to get you into their engine for free? And then what is the best way for them to make money off it? The same problem if you're making a free-to-play game, which is, well, how do I give my product away for free and then make money from it? Unity and Unreal, just to pick on the top two, have two different business models. Unity ultimately charges a specific price if you ship your game on their platform, and a different pricing structure if you're an indie and your revenue is below a certain threshold, and if you're a larger company and your revenue is above a certain threshold. Whereas Unreal wants 5% of your gross revenue once you launch your product. So up until you launch the product, you can pretty much work with their tools with a few exceptions. But once you launch your product to the mainstream, okay, now is the time where you have to worry about how do I pay? Do you guys have anything to add to that?
Yeah, actually, I have a few things to add to that. One is on the business side. One of the reasons from that free to play is so attractive is the ceiling of revenue is much higher. If you have a huge hit AAA game, Call of Duty makes, a single Call of Duty game that's packaged and sold and you buy it and you own the whole game, you're looking at maybe $2 billion worth of revenue. But a game like Candy Crush is, it's over $10 to $15 billion now. So, and that just keeps going because people can continuously pay for it. Another thing is from the game design perspective, when you build a packaged premium game, you build it the best you can and you put it out there and hope people like it. When you're building a free-to-play game that's gas or games as a service, you can then look at the metrics, see who's playing, see where people are getting stuck, and you can go in and tweak your game and continuously make it better and better, which is very useful to game developers. And then the last one is free-to-play isn't really new. Jeff can speak to this, but there's very little difference between buying gems and plunking in quarters like we did in the 80s. It's kind of the same thing, just in a different way. Instead of standing at a big cabinet, you're now looking at your phone. Yeah.
Okay. Would you like to add anything, Dan?
Yeah, well, we developed a game engine for the educational sector, and that was kind of, it has been an interesting journey for us. I think it's an interesting challenge for anybody who's looking at the games for learning space. Was learning that our users were kids, and kids, they don't even have any money. So, our figuring out who your customer is obviously always very important. In our case, the users of our game engine are kids, but the people who are the gatekeepers, if you like, are their parents and schools and teachers. So making the barrier as low as possible for those people, for us, has been really important. And I think whatever game engine you choose to use, you just have to make sure it's the right engine for the job. Our one is all about learning about game development.
Great. Okay. So game engines are also used for non-entertainment purposes. What are the most common usages for game engines other than making games?
Having talked to a lot of my reps at the different companies, Unreal is actually starting to get a lot of traction in both movie making, so that it's really fast to do previs stuff for movies, and also architecture. So an architect could build a whole building and throw it into VR, and you can actually be standing in the middle of a building that will be built someday. So those are the two ones that come across the top of my head right away that I hear a lot about.
Yeah, here in Salt Lake, where I'm based, we actually have a couple of movie studios that have built full green screen and blue screen environments and are using Unreal to do all the previs and real-time editing and dailies for their shots. The actors may have a green table and a chair, but then you look at what Unreal's providing, and they're in a cabin in the woods somewhere or something. So that's a wonderful place to see these engines go. It used to be, even though it's the same thing, if you weren't using it for a game, it wasn't an engine, it was a 3D authoring tool. They do the same thing, but just different terminology. So if you hear the term 3D authoring tool, it really does kind of the same thing. And one of the other applications you see a lot with Unity is non-gaming apps. Unity is, you can still put menus on the screen, do 2D things, or even incorporate AR systems and such. And so you see a lot of the apps on the mobile store are all built in Unity, even though they're not games themselves, which is a huge market also for Unity.
And Unity makes it very easy to... Sorry, I was going to add that Unity makes it very easy to push it right out to those mobile platforms, and that's a lot of the reasons it's used that way.
I see. Would that be actually efficient to use the Unity game engine for this?
Sorry, could you repeat that? I missed the first part.
Yeah, so Jeff mentioned that some apps actually use Unity, even though they're not actually games. So would that be actually a good choice concerning like performance and technical issues?
I think so. Yeah, it handles so many easy things for you, and there's a lot of plugins you can get right off the asset store to handle like multi-platform logins and stuff to you. And they have the Unity Cloud build. You can click a button and push your build right to your Android test bed. It makes it really easy on a lot of things. And it's not really specifically a game engine. It's just an engine.
Right. Okay.
We used to have to make the rendering component of our engine support every different platform, because every console, every device has a different way to put, graphics on the screen and process it. One of the nice things of these engines, specifically Unity and Unreal, is you as a developer don't have to think about that anymore. And it used to be a really, really hard problem to solve. So, that's one of the reasons, like John was saying, these are great tools to do non-gaming things because you don't have to think about that rendering and that hardware component anymore.
Right. Dan, you wanted to add something?
Yeah, we see a lot of 2D game tech used on websites just to make websites more engaging. Some of you might remember the days of Flash, and while a lot of people criticized Flash-powered websites for being slow or overly memory consumptive, they looked great, and I think the internet and websites in general have looked just very boring for quite some time. I'm hoping that HTML5 and new JavaScript technologies eventually bring back another kind of era of really engaging, visually rich web tech and web apps. And I think gaming technology is also being used on websites to make websites more usable. So you're starting to see websites with elements of heads-up displays and using game design technology and techniques to make those websites more accessible. And I think we'll see more of that. I'm not sure if Unity is the job for doing that. I don't think it necessarily is, but I think the web industry has a lot to learn from our industry and games industry in general.
So Unity at the moment also supports WebGL. So would you even consider now making websites just like Flash using Unity HTML5?
I think if you were to use Unity to build a website, you would have to be very conscious of who your user is. The Unity engine has a lot of bloat with it for WebGL content, not for just if you're making a real game for an app purpose, then I think that's obviously the right use case. But for us, we're making games for kids who have limited data on their mobile phones, just as an example. So you don't want to be using an engine that has 50 megs of nothing apart from just whatever engine stuff comes with. It's sort of considered bloat, and you don't want a scenario where a user can play one game and then that wipes out their bandwidth for the week.
Oh, yes.
So yeah, just being careful of what you use and who you're using it for.
Okay. So I guess choosing a game engine is a very important decision in the game production process. I'm pretty sure lots of people will be like, okay, what's the best engine to start with, or what is the right engine for me or for my game, and why would you even choose an engine? So if we can have your input on this.
If I was starting out, I work with a lot of indies. I've been in indie for a long time. I worked at Tiny Build, who's an indie publisher. I tend to recommend Unity. Unreal is in my opinion, the easiest way to get something really beautiful up on the screen quickly, but it's more geared towards artists and engineers, whereas I feel like Unity is more geared towards all developers. But no matter which one you go to, you look at their asset stores, and there is a ton of plugins, assets to get started with, more than most other engines you'd see. So starting at either one of those is a really good choice. And just the resources online for tutorials, YouTube videos telling you how to do stuff. There's so much of it out there that you can easily start and get something to screen very quickly. That's why I would recommend.
Yep. And I think when to add to that, when you're starting your game, usually most developers are thinking, hey, I want to make a PC game. I want to make a mobile game. I want to make a console game. You're kind of thinking, or VR, you're kind of thinking of, all right, initially, what do I want to do with it? And I think that helps your decision on engines as well. For example, I would not consider Unreal if I were making a mobile game. Unreal is great for high end, but because of its memory management and its processing power, there's very, very few games that exist on the mobile store that were even attempted with Unreal or the mobile version of it. Whereas Unity, like John, you were mentioning earlier, natively out of the box becomes really easy to click a button and you can export for Android and iOS, and all the tools are there, and it's really simple. and you don't have to be a die-hard engineer to get something up and running. Even if you don't know C#, there's enough forums and groups out there where, hey, even if you don't know what the code does, hey, I need a third-person follow camera. You can copy somebody's code, plug it in, and now you have a third-person follow camera, and you can follow your character around. In addition to all of the other assets that you can buy out there. So I think looking at what your end platform is helps you a lot in make those decisions.
Okay. Would you like to add anything, Dan?
Not really. I think Jeff and John nailed it.
Well, there was I don't know if we should be answering questions, but there was a question that popped up about Game Maker.
Yes.
I've used Game Maker. It's not to throw shade. It's kind of like my first game engine, but it does not do nearly as good of a job. If you want to build something specifically for PC and you're just starting out, use Game Maker. But if you want to build something that you would really like to show up on a Switch, an Xbox, a phone, a PlayStation, using Game Maker is going to cause you a lot of problems getting it ported to those platforms. That's why I recommend Unity or Unreal.
Okay.
It's really interesting, though, because we were doing some work a few years back. We were talking to one of the Disney channels, and they've got really, really tight restrictions. They're like, your game has to be this big, or it won't make it onto our mobile platforms. And just out of the box, some of those frameworks were like the Unities and the Unreals. They produced games that were just too big for those platforms. So I think it's worthwhile being conscious of those engines and the affordances of them. Sometimes you might just have to use an engine like that to create a game that's going to fit your client requirements. And there are some big clients out there. Snapchat at the moment, they recently bought an HTML5 game framework because obviously their platform and their users are on mobile, and the games have got to be tiny. Otherwise, they're just not going to load quick enough.
Yeah, sure.
Go ahead, John.
One, I agree with Dan completely on that as well. One other thing is, if you plan on having a studio that grows, hiring people that have Unreal or Unity experience is a whole lot easier than finding people that have experience in other engines.
Mm.
The only thing I was going to add was thinking about the genre and type of game that you're going to make is also important. For example, if you want to make a first-person shooter, you're not going to use Game Maker or Cocos 2D, for example. So, thinking about what is your end goal, what is the type of thing you want to do, and everything from the camera to the movement system is a big deal, because each of these engines we're talking about do have different pros and cons of the type of experiences that they do natively or well, and some that you're going to have to fight with in order to achieve your creation.
Even with the big ones, it looks like we lost Abdullah for a second. So even with the big ones, like if you want to make a networked game, Unity does not handle networking very well. Not very well at all. Unreal does a fantastic job on it. So if you want to make a big multiplayer game, you might lean towards Unreal. So there's each one has pros and cons.
If you wanted to make a vertical shooter, depending on your design, okay, you might be able to make it in Game Maker. You do have the other issues with portability and stuff. But if you wanted to make it all with 2D and 2D sprites or cell animation, okay, maybe that gets you your start. Yeah. Versus you could do the exact same game having lush, high poly 3D environments instead and make it in Unity and Unreal. So part of your rendering and your asset pipeline can come into the equation.
Okay, when you mentioned about small file sizes, you notice sometimes people tend, especially in mobile, they tend to go to make native code instead of relying on a third-party game engine or anything like that. So is that really necessary these days? Did the applications, did the mobile devices improve so that we don't need to take such actions anymore?
Well, any of these engines are going to be basically fast enough to run on any mobile device nowadays. But you still have to be careful of how you author all your content. If it's too big, It takes a long time to start. There's a lot of evidence of like, if your game takes too long to start on a phone, people aren't going to play it. You know, so it's more about the content you put in than the actual engine when it comes to performance. When it comes to file size, most engines have some hoops that you can jump through and use, slowly download content over time, so the game starts, you're downloading content in the background. Actually, some of the, I'm not sure if it's true anymore, but some of the mobile platforms actually required certain apps to be like under 100 meg, or else they wouldn't allow it to download over self-service. So the mobile games that I worked on, we did a lot of effort to make sure that they were under 50 meg, so they would download quickly and then pull down other content after the game was there on your phone and started.
Right. And that type of architecture exists independent of whatever engine you use. Because those rules, especially from Apple and Android, okay, the rules remain the same, and you just have to figure out how are you going to solve it with the engine that you're working with.
Okay, so we did a question from the audience. They're asking, should you ever build your own game engine, and why would a company even decide to make their own game engine?
So go ahead, Jeff.
So I'll start with that. That used to be the way that the entire industry worked. You go back 15, 20 years and before, every development studio had their own in-house engine that they tried to support, sometimes making brand new engines for their games. And usually the reason is because the previous engine, or the ones that they used, or the ones that they bought, could not do something that they wanted to do for their game. Or it was too hard to work, or it was too bloated. They needed something simpler. So if you wanted to write your own engine, the question I would ask is, okay, what do you want it to do that what's out there in the world currently does not offer, or you cannot do with it? And at least that's the place I would start if that was a realistic conversation.
Yeah. I know there's also concerns about some of the bigger companies, one, like owning all the tech. They don't like paying Epic 5% of their, the money they bring in. So there are business reasons for building your own. And then some of the indies I've learned is just, they love graphics tech, so they wanted to build their own engine because they wanted to build a graphics tech. So that's fine too. But those are the two big reasons I see.
When I was at EA, it was actually frowned upon to suggest using Unreal. Like, no, don't pitch a game with Unreal because of the costs and everything. We use something internal was kind of the model. And due to the complexities of creating these things, eventually that turned a corner, and they stopped looking down on people recommending an Unreal Engine or a Unity-based product, and kind of said, okay, you're the game team, you make the decision of what works best for you. Was kind of how it evolved.
So Kat, so you did mention if a certain functionality does not exist in a game engine, then that would be a reason to make something your own way. So wouldn't you be able to just extend the functionality of the current engines to achieve the extra functionality you want to achieve?
In fact, go ahead, Dan.
I was going to say there are entire marketplaces within the Unity and Unreal ecosystem that exist exactly for that purpose, and there are a lot of developers out there and artists making a lot of money filling those gaps.
There are times where a new technology comes along and those engines don't support it. That happened in very early days of VR. So yeah, that's sometimes those situations you have to do it as well.
Okay. What if you want to add things like your own hardware to the engine? You want to support your own hardware.
Jeff, you're the arcade guy.
It's more complicated. So, for example, if you wanted to add a piece of hardware that had unique rendering and processors that, let's say, Unity did not natively support, you have two options. One is talk to Unity, say, hey, can you support my hardware? And give them a reason to do it and to put staff against it. That would be less likely depending on what your business model looks like and stuff. Or you negotiate with them to give you access to their source code and then you write an updated renderer that works in their source code with their engine that you could then give back to them for future support. I've been involved in deals with Unity specific on both of those sides. So they are open to it, but you essentially have to convince them why it's important and why they should be involved. And getting access to their source code to do your version of it does require a lot of hoops to jump through.
Okay. So we notice now that some companies are actually ditching their own engines. So they're actually now jumping to engines like Unreal or Unity. So what exactly happened?
Meaning, if a new company puts an engine out there, how do they get?
So currently, lots of companies decided to use Unreal Engine or a third-party engine like Unity instead of using their own engine. So that decision must have come for a reason. So what are the reasons that companies decided not to use their game engines anymore?
I would say one of them is speed and efficiency of development. When you write your own engine, you're constantly updating it, maintaining it, improving it, which means a large portion of your staff is literally not making the game. They're making the engine and furthering it to help you, make the game that you want. If Unreal or Unity or Crytek or something else has the features that you want, in many cases, it's cheaper to use somebody else's than to build your own, especially if the end result is the same. On the subject of why would an entire studio or company adopt one engine, it's because the knowledge base of people learning the ins and outs and the guts of the engine can be amortized better across all of the teams, and you're building a common mind share. The opposite of that is you have 4 different game teams working in 4 different engines, and you can share nothing between each of those teams because they all have a completely different experience base and knowledge base. Does that help answer the question?
Yes.
And also what I mentioned before is if you plan on growing, it's easier to hire people that know those engines.
Absolutely, yes. Because there are also cases where the knowledge actually go outside of the company, and then the remaining employees don't know how to use their engines anymore because the senior people who used to use the engine left the company.
It's a bit of a catch-22 because the universities, and some of them in New Zealand, are producing a workforce that can use Unity or use Unreal as opposed to somebody who can really sink their teeth in and code all the crazy things that you might come across in a game. So it is really interesting that some of these developers actually come out with less programming skills and more tools skills, and that, there's pros and cons with that. And I think that will change and evolve as industry works closer with universities. At least that's how it is here.
Right. Danny also told me about that you really like the block-based coding system. So can you talk more about that, please?
So block-based programming is visual programming, and it was sort of developed a number of years ago by MIT in the States. And it's a way of programming visually where you're dragging blocks of code around that have the real syntax underneath them. And when they run, they just run like real code. So Scratch is a tool used by kids to learn to program, and we give kids tools like Scratch because they find it engaging, and it's a way of getting young people interested in what we do as developers. If you throw a text editor or Unity or Unreal in front of a real young person, we might actually lose them, which is the opposite of what we want. When we're trying to grow a workforce, we also really want young people to be programming and learning to code games versus learning to code websites or whatever else it is we're sort of talking about, or whatever educators are using. And Google also recently launched a platform called Google Blockly, and that's become very ubiquitous in sort of certain areas. It's an open source product that we use it in GameFruit. It's got JavaScript running under the hood, and again, I always sort of go back to engagement. And at some point in time, once you've used Visual Code for long enough, you hit a point where you're like, okay, now I want to use a real engine. I want to make games for a career. I know what I want to do now. So it's about sort of gently stepping people towards us as an industry in a way that we think works for them.
I think that's also part of the accessibility. I mean, even so Unreal has a block-based coding schema. I think also Unity is trying to do something similar right now, if they didn't do already. So is that like their way of trying to get more non-programming people into using game engines?
I think
Absolutely.
so.
Yeah.
I kind of sometimes wonder about this. I think, Unity and Unreal are so good at what they do. Why would they be jumping into this sort of space? Which is perhaps something Jeff or John could maybe kind of better articulate than myself. I come back to, is it really the right tool for the job? Do we really want to throw Unity in front of a 12-year-old?
I kind of look. Oh, sorry, Dan, didn't mean to interrupt. I was going to say, I kind of look at it basically exactly what you said. It allows artists, designers who aren't coders to get in there and do something. So as from like a business runner and design or a game director point of view, games to me are all about iteration. You get it to screen as quickly as possible, see what's works, see what doesn't work, do more of what's good, less of what's bad. And if you can get your artists and your designers in there, trying stuff out, throwing it to screen, showing it off to other people, that makes your engine way more effective than only having the engineers be able to make effective change to your game. And I think Unreal and Unity are seeing that.
There's I would say there's a holy grail when it comes to game engines here. And that holy grail is artists and designers can make whatever they want without the need of engineers. Not saying that the future is doing away with engineers, it's the exact opposite, but that's kind of this weird holy grail that everyone I've known that's been involved with engine development, the goal is to continuously push your user interface, your development, your WYSIWYG functions, whatever it is, to make it so that designers and artists can build 98% of your game. And when you get there, you're absolutely right. It allows more iterations per day. Like I judge success on how many iterations can we do in a given day, because that's when your great games happen. And if your iterations are, all right, here's the idea, pass it to the engineer, pass it to this guy, and a week later we get a look at it, okay, that iteration is really slow. Versus, hey, can we look at 3 different lighting changes in the course of the next 2 hours? Okay, that's really fast. That's really good. That's why I think there's this weird holy grail that I don't think we'll ever get to. But I think that also is what gave rise to things like Visual Basic for a while. Hey, how can I program in Basic by knowing nothing about Basic? Right.
Well, actually, I think part of the reason you're seeing a lot of adoption of AI and machine learning in games is to get closer to that holy grail.
How so?
Just you're already seeing opportunities in creating terrain, procedurally generated content. So a designer can sit there and say, these are the kind of things I'm looking for. And a machine learning AI will go ahead and generate 1,000 different levels for you. You're actually even getting to the point where you can kind of just say, hey, these are the things I'm looking for, and it'll generate an art style. It'll generate I've even seen some very early prototypes of generating UIs for you or gameplay mechanics. So, I mean, it's not coming tomorrow, but in the next 10 years, you may see us get very much closer to, hey, you got a game idea? You can get something up and running just by talking to a computer.
I see.
It'll be interesting to see how that plays out from a consumer point of view, though. Is the world going to be riddled with more cookie cutter games? How does the narrative come into that? And how does the music come into that, and all of the things that we love about games and that we loved about games growing up playing them? Can AI really give that justice?
Well, my hope would be that the really brilliant designers that have something interesting to share are the ones that kind of rise to the top and get the notoriety. I mean, we have a ton of cookie cutter games now. So, just look at the mobile store or Steam and you'll see a lot of them.
So Dan, I noticed in the website when you try to make your first game, it's kind of the first game is already there. There's a template, so it's very easy to get in for a young person. It's quite easy to use. The game is there. You start building it and you start experimenting. I think with the block system definitely helps, but I don't think it's the only thing to consider when trying to when targeting young ones, because you're kind of eliminating all the gamey things and just making them get into it immediately.
Yeah. That wasn't so much a question, more of a statement.
Yes, true. I just thought you would comment on that.
Yeah, you've got me thinking. Yeah, I think you've done a good job of describing the entry into the Game Fruit world we've kind of created. And like the other panelists have been talking about, our job is to continue to iterate on the GUI, to iterate on the features that we can to make Game Fruit more and more engaging, so that it's easier. I guess what we're trying to do is make it easier to make different types of games, different types of game prototypes really fast. So Game Fruit's really good at making platformer games. It's getting better at making top-down RPG games, and it's going to be pretty good soon at making interactive fiction games. And that's kind of what we're good at. We don't expect users to really go outside of that box much. And so a good job for us is when we've nailed that user flow. So you're like, okay, I've learned a little bit of platformer game thinking. Now I can go forth and make my own platformer game. We've done the stuff in Game Fruit that gives me the skills to go forth and make my own game now. And whether that's a top-down, a platformer, or an interactive fiction, that's kind of what we're thinking of. Those three game types lend themselves really well to learning and education, partly why we're focusing on those. Because if you're a kid and you're in school and you're meant to be learning language skills and you write an interactive fiction story, you're going to be making teachers happy, you're going to be making parents happy, and you're going to be making, and you're providing those kids a really enjoyable language skills lesson. And so they're more likely to engage with their learning that way. And similarly, if you're making a game about a local hero or a historical figure, a myth character, suddenly learning by making your own RPG game or platformer game becomes a whole lot of fun. And we can also point to games like Angry Birds or some of the early 2D games in the App Store and go, look, real game developers are making these games, and they're making these people real money. So, why should you be venturing too far away from these? Like if you look at a platform game, you can say they're never going away because they keep popping up and they keep being successful. I think, even Capcom releasing Mega Man 11 last year, it was a fantastic game. And we can show kids that and go, you're this close to making a game like this. And that's how we get kids excited and hyped about making games and putting them on a career pathway to, game development as opposed to, say, web development.
Mm-hmm.
I'd like to add one warning about that for the kids that are out of high school and looking to get to be real game developers. With all these tools, it makes it really, really easy to start a game and try out your ideas, and that's the fun part. But the absolute biggest recommendation I give to anybody trying to get into the industry or build a game is learn how to finish. Because you'll get past the really fun part and you'll get bored with it. You go on to a second idea and a third idea. But everybody that ships a game or is looking to hire somebody, they want to see somebody who's finished a game. Somebody so they can look at a game that looks like it's ready to go on a platform or ready to be shipped to, not in a box anymore, but ready to be shipped somewhere. And with it looking that easy to make a game, just be very careful and make sure you finish something and ship it, because that is what employers look for.